Welcome to my channel. In this video, we are going to be taking a look at how to calculate the height of a bouncing ball. So we have a problem in the form of a diagram. So we notice that when a ball is released from rest, as it strikes the ground, it bounces off and bounces off several times until it comes to stop. So sometimes we might be asked to calculate this height of the first bounce. Then maybe we might be asked to calculate the height of this secondary bounce and so on and so forth, probably in terms of this original height, right? So let's see the question that arises. If a ball is dropped from a height h and rebounds back to a height h1, find h1 in terms of h and the coefficient of restitution. Also find the height hn for nth rebounds in terms of h. So we have the height, original height, to be h, capital letter H. The first rebounds, we have it as h1. Second rebounds, we have it as h2. Then third rebounds, we have it as h3. So on and so forth. We have h4 until it comes to stop. So to solve this problem, the first thing we need to do is to calculate the velocity with which this ball strikes the ground. Then we can now apply the principle of momentum. Okay, so to calculate this height, we use this formula, which is VB squared equal to U squared minus 2GH, where our H here is this height. Then U squared here is the original or is the initial velocity of the ball when it is released. Then this VB is the final velocity just before it strikes the ground. Now, when it is released from rest, the initial velocity is 0. And we also need to take note of the fact that since it is going down, then we take our h as negative. So in that case, we have VB squared equal to 0 squared minus 2g minus h. So as a result, we can make VB the Sevier formula. So that will give us VB equal to plus or minus square root of 2gh. So this VB is the velocity of this ball before it strikes this ground, right? So if that's the case, then the velocity when it strikes the ground and leaves this particular and travels this height can also be determined from this one using the coefficients of restitution formula. And that's giving us E equal to VA minus VA all over VB, where this VA is the velocity of this ground after the impact, while this one is the velocity of the ball after the impact. This one is the velocity of the ball before the impact, velocity of the heads before the impact. Now we notice that VB is already known. This one is known. We are interested in finding this one. But VA, which is velocity of the head after and before, will be 0. Why? Because the head doesn't move when there is collision between the heads and this one. So we take this one as 0, take this one as 0, and we're fixing this E equal to 0 minus VA divided by minus VB, because this particular ball is traveling towards, so we assume that it's taking negative. When it is traveling away from the head, we assume it is positive. So this VA away from the head, which is after, is positive, towards the head is negative. So as a result, from here, we can make VA the Sevier formula. Everything comes towards this side. Minus and minus will take care of each other. So we have VA equal to this. And VA equal to E. We already know our VB, which is plus or minus 2GH. So we take the positive part, which is VA. Why? Because our VA is traveling backward. It's traveling away from the earth, which is positive. So we'll take the positive parts. Right? So now that we know this, the velocity at which this one hits, the velocity after collision, the velocity with which it goes back, we can also find this height traveled. And to find the height traveled, we use this same formula, which is given as V squared equal to U squared minus 2GH1. We now know the initial velocity, which will be taken as this expression. When it gets to this maximum height, the velocity there will be 0. Then we can calculate the value of H1. And that gives us 0, that's the final velocity when it gets to that maximum height, h1 will be 0. The initial velocity has been calculated, which is the velocity after collision, which is this, minus 2gh1. So from there, we can resimplify by sending this one to this side. We have this, if we take the square of everything here, it gives us e squared 2gh equal to this. We can take care of 2g so that we have our h1 equal to e squared h. So this is the connection between h1 and capital letter H, which is the original height. So we might be asked to solve a problem when h is given and the coefficients of restitution is given to determine the h of the first rebound, the height of the first rebound. And let's look at a problem. If h is 2.5 meters, e equal to 0.75, what will be the value of h? What will be the height of the first rebound? And that will be giving us h1 equal to 0.75 equal to 0.25 meter. And hence we get our h1 to be 1.406 meters. The coefficients of restitution, which is this, right, relates the connection between two objects that are colliding, right? So the height, if this part, the maximum value that E can take is 1, and that is for a perfect elastic collision, and the lowest value that this one can take is 0, that's for inelastic collision, right? So if it is in between, if the value of E is in between 0 and 1, that is a realistic scenario, real life scenario, right? But if it is perfectly, it is an ideal situation, and if it is equal to 0, it is an ideal situation. So let's see how we can also calculate the value of h2 in terms of capital letter H. So we start with this same formula. We have, this figure. So we assume that this one is the first rebounds, second rebounds. First rebounds, we get this height of h1. Second rebound, we get the height of h2. Third rebounds, we get the height of h3. Right? So we have to determine the velocity before second rebounds. Right? So what that means is that since we know the velocity with which this one strikes and the velocity with which this one leaves, it's important for us to know the velocity with which this one strikes the second rebounds. So to calculate this one, right, we must assume that the ball, when it is originally here, travels a distance h1, right, and we need to calculate the final velocity when the initial velocity is 0. So in that case, we say, using this formula, VB2 equal to u squared minus 2gh1, right? Our initial velocity, when it is at that height, is equal to 0. Then we're interested in calculating this one. Remember, our h1, because it's traveling back down, it takes negative value. So we have VB squared equal to 0 minus 2g minus h1. And we can make our VB equal to 2gh. So we move on to VA, because we have already established a connection between the before velocity and after velocity, right? The connection between before and after using these coefficients of restitution. If you check the previous slide, you notice that to get the after velocity, that's with which it leaves the heads, just multiply E to this one, and that gives us the value. So with this, we can go ahead and compute the new velocity with which it leaves, the height with which it leaves the heads. Now, as it leaves, this VA will act as the initial velocity. When it gets to the second height, the height of the second rebounds, right, this one will now become 0. Hence, when we substitute this one into this one, we get 0 equal to u squared minus 2gh, and we have VA squared. We already have VA squared, right, coming to this part, equal to 2gh. Now, what is our VA squared, which is expression here, and that gives us E2gh1 2 equal to 2gh2. And we can now say this expression is equal to this expression, right? So we can take care of our 2g and make h2 the Sebier formula, and that gives us h2 equal to E squared h1. But we know that h1 is connected to capital letter H, and that gives us E squared times E squared H, which is equal to H squared. So as a result, we can make our h squared, we can rewrite it in this form. So h2, so h subscript 2 is equal to e raised to power 4h. So this is a connection between the second height of the second rebound, right, in terms of capital letter H. So if you see, there's a connection between H2 and this in terms of E4. So in case we're asked to find the nth heights of the nth rebounds, the general formula will now be equal to Hn equal to E raised by 2nh. And that's it. I hope this helps. Please like, share, and subscribe. Thank you.